Hello, and I hope you all are doing good. My today's video is about fundamentals of networking, and we will start from very basics. We will see what is a bit, what is a byte, what is an octet, and how can we convert a binary into decimal, and then from decimal to binary. So let's start. So when we talk about networking, it means we are trying to connect two or more systems. And when we want to connect two or more systems, we need to establish one important point, which is the addressing. So for example, we have this machine 1, which I will write here M1, and we have this machine 2, which is M2. Now, machine 1 and machine 2 want to talk to each other, and they are connected via a local network or the internet. Now, if machine 1 wants to send some data to machine 2, then what is the important point here? The important point is the address. Machine 1 and machine 2 needs an address, and this address is represented by an IP address. So this is an IP address. An IP address is a number which is divided by dot, and these are 4 numbers. So here you can see the machine number 1 has an IP address of 128.0.0.1, and the machine 2 has an address of 192.0.0.10. Now, what is this IP address? What are these numbers represents? And how machines understand this number? We will now discuss this in detail. Let's take an IP number. So here is an IP number which is 10.0.0.1. Now, this IP number is composed of 4 numbers, and one number, for example, this number is an 8-bit number. Now, this is 8-bit. Likewise, the second number is also 8-bit, the third is also 8-bit, and the fourth is also 8-bit. In total, these are 32-bit number. And machines understand bits. Machines don't understand numbers. So whenever we give an IP to a machine, it converts it into bits. Now, how can we get this bit? Let's try to understand that. Now, let's see what is a bit. A bit is actually a combination of 2 numbers, 1 and 0. A bit can be of 1 or a bit can be 0. So 1 can also mean true, and 0 means false. 1 can also mean on, and 0 means off. So the bit is just either 1 or 0. And with this combination, we can generate the IP address. So this is the decimal presentation. This is the decimal representation. And then we have another representation, which is the binary representation, which we will discuss now. Now, how can we represent this in binary? Let's see that. Now, here you see I have a simple table, and in this table I have 8 bits, and these 8 bits are right now off. I have given 0 to all the bits. Now, this 8-bit is actually 1 byte, right? This 8-bit is actually 1 byte. Or we can also call it's an octet. It is also called an octet. So 8-bit number. So now we have this 8 bits, and these 8 bits actually represents some power. They have some weight. For example, let me show you what are those. So the first bit is considered as 1. It has a 1 power, or you can say this number represents 1, or it has a weight of 1. The second is 2, 4, 8, 16, 32, 64, and 128. So these bits contains or represent some numbers, or they are represented by some powers, and these are the numbers they represent. And if you closely look at these numbers are in a specific pattern, and that pattern is actually 2 to the power of something. Now, what is that? Let me show you. So the 1 is actually 2 to the power of 0. The 2 is actually 2 to the power of 1. 4 is actually 2 to the power of 2. And in the same way, we will move forward. 2 to the power of 3 is 8. 2 to the power of 4 is 16. 2 to the power of 5, 2 to the power of 6, and 2 to the power of 7. So these numbers are actually in a specific pattern, and that pattern is a 2 to the power of something. Now, if I want to make 10, now this first octet, now how can I create this first octet, and how can I represent this first octet in binary? So let me take help from the same chart and try to create the binary representation of 10. Now I have this table, and I have all the powers, all the numbers here for the of the binary representation. I want to convert 10 into binary. So for that, I will compare 10 with these powers. Is 10 greater than 128? No. So it means it's false. I will say 0. Or I can also say I will make this bit off. So I am making the bit of 128 as off. Is 10 greater than 64? No. Make this bit off. I'm off. I'm doing 0. Is 10 greater than 31? No. Make this off. 16? No. Make this off. 8? Yes. 10 is greater than 8. I will turn this bit on, and I will write 10 here. 10 minus 8 equals 2. So I need a bit of 2. So is 2 greater than 4? No. Turn this bit off. Is 2 greater than equals to 2? Yes, it is equals to 2. Turn this bit on, and 1 is 0. So, and now I will count and I will add those bits which are on. So 8 plus 2 is equals to 10. 8 plus 2 equals to 10. And this is how we got the first bit. Now for the second bit, which is this is how we got the first representation, the decimal representation of our IP address. Now let's go to the second number, which is 0. For clarity and for showing you in a proper manner, I have drawn these 4 tables, and I have written the IP address at the top. And now we will try to convert this decimal IP address into binary. So if the first one we got it, we have the number 8 bit on and number 2 bit is on. Now for the second, which is 0, and for the 0, it's very obvious what we are going to do. So we will turn all the bits off. So I will say 0, 0, 0, 0, 0, 0, 0, and 0. So when all the bits off, it means it is 0. So this is actually 0. And same will be applied for the next one, because this is also 0. So I will say 0, 0, 0, 0, 0, 0, 0, and 0. So this also means 0. Now the last bit I have, the last number I have is 1. And as you can see here from the chart, the last bit is 1. So I just need to turn this on, and I will keep other as off. So I'm turning all the bits off. So this is 1. Now, what is the representation of the decimal representation? It's very obvious now. So the decimal representation for this one is 0, 0, 0, 0, 1, 0, 1, 0. This is 10. Now for 0, all is 0, so I won't write it here. So all is 0, it is 0. This is all is 0, and this is 0. And for the last one is 0, 0, 0, 0, 0, 0, 0, 1, and this is 1. This is how we can convert our decimal IP address into binary, and the machine understands this binary. So in the next lecture, I will try to explain a bit more. We will take some more IPs and we will convert them from binary to decimal and decimal to binary. Thank you.